SwayamPrabha. Digital India. Educated India.
Good morning everyone. Now we will start a new module, densification of solids. In the last modules we have discussed on different thermochemical conversion processes like incineration, gasification, pyrolysis, etc. And we have seen that uniform feedstock properties are very important to get better performance of the process. And we have also seen that in these processes some pre-treatment step is required, which requires the feed materials to have some mechanical shock resistance properties. Thus, any solid materials having uniform properties like higher density, uniform particle size, etc., and is very important for the getting more efficiency of the process. So, densification is such a process which imparts these properties to the biomass and waste which is available in nature. So, these biomass and waste available in nature are not having these properties. So, densification helps to improve the uniformity of the properties as well as it gives a uniform particle size. So, in this module we will see what is densification, fundamentals of densification, types of briquetting processes and their comparison, carbonization process, carbonization reactor, briquette characteristics, application of briquettes and manual briquette machine. So, when the briquettes are formed, then those are used for further applications like incinerations or gasification, but as such if it is used then it produces very larger amount of smokes. That is why the carbonization is followed to reduce the smoke or fumes less production as well as to improve the fuel quality of the material. Now, let us see what is the definition of densification. So, densification is the process which increases the density of any material. When it is applicable for fuels, that increases the density of the fuel as well as it gives some uniform properties like uniform particle size, the higher density, etc. So, what are the advantage of this process? The advantages are that this is simplified mechanical handling and feeding, and then uniform combustion in boilers. When the briquettes are used in boiler, then due to their uniformity in properties like particle size, the combustion is more efficient. So, that is why uniform combustion in boilers, reduced dust production as the smaller particles are not available in this material. So, reduced in dust productions and reduced possibility of spontaneous combustion in storage, simplified storage and handling infrastructure, lowering capital requirements in the combustion plant, and reduced cost of the transportation. As the material becomes dense, so the energy density increases, that is why the reduced cost of transportation due to increased energy density. But this process has some disadvantage because it includes some cost for the productions of the briquettes. Now, let us see how the briquettes can be produced. So, for the production of briquettes, at first the particles are compacted, then it is compressed and then concretion, and then finally we get the concentration of the particles and we get the densified material. Now, let us see the mechanism. If we take some material, solid material, so it will be having some particles in it. So, those particles will not be very close to each other, but it will be maintaining some distance, although they will be having some interactions, but there will be some separation between these two particles, and this is due to the van der Waals forces. Van der Waals forces or electrostatic attractions, electrostatic forces. Now, if we increase the pressure, then the particles will come closer, this particle will come closer. So, this distance will be reduced. Further, if we increase the pressure, then the particles will be interlocked. So, particles will be interlocked. This interlocking will depend upon how efficient this interlocking is, that will depend upon the properties of the particles. Means what is the composition of these particles? If these particles contains a ligneous material, so this will be more stable. Otherwise, these particles again will try to springing and to be separated from each other. That is why some binding agent is used. So, some binders are used so that the particles which are being interlinked will not be separated. So, for the productions of briquettes, we can see we need to put high pressure so that the particles will come closer and will be interlocked, or we can add some binders. So, some materials are there for which binder is essential, but some materials are there if we apply high pressure, binder is not required, and the binder helps to bind the particles. The binder helps to bind the particles and keep them close. That is why in this process the pressure requirement is not so high. So, now for this clogging interlocking purpose, what should be the pressure range? That is around megapascal in many cases or more than this. Now, we are getting two situations where we are having high pressure and another in case low pressure. So, the briquette formation can take place either in high pressure condition or in low pressure condition, or in between there will be some intermediate pressure. Conditions. So, this is the mechanism through which the briquette is formed. Now, let us see some information here. Some additives which are added here, those are maybe organic or inorganic in nature, like say tar, molasses and other higher molecular weight organic compounds can be used, and these additives which binds these particles by the cohesion and adhesion. So, cohesive forces among these solid particles and adhesive forces between solid liquid particles. So, they bind the materials or the particles of the materials, and when the high pressure is applied, lignin present in the biomass and waste comes out and helps for the binding. So, that is called indigenous binder. So, lignin presence means the lignins will come out of at high pressures and it will help for the binding. Otherwise, we have to add some external binding agents like say molasses, tar or other organic molecules. So, the densified material which is formed through this densification process may be either in briquette forms or in pellets forms. So, briquette and pellets are separated on the basis of their diameter, but there is no very sharp distinction. Normally, if the 30 millimeter or less diameter, then it is called pellets, and if the size of the particles are more than 30 millimeter, then it is called briquettes. So, as shown here, this is the example of briquette and this is the example of pellets. Now, there are some factors which influence the performance of the briquetting process. So, those are out of those some important or physical properties that is what is the moisture content, what is the bulk density, what is the void volume, what is the temperature, thermal properties. So, all those things will influence the performance of the briquetting process, and ultimately after briquetting what will be the density, of the briquettes, that will be guided by the process used, whether it is high pressure or low pressure or type of material. Some other factors are also there, but these are two major factors which influence the final density of the briquette. Now, we will see how many types of briquettes are available or briquettes can be produced. So, we have seen that high pressure, what is that high pressure? Around 100 megapascal or more than this. Intermediate pressure, that is 5 to 100 megapascal, and low pressure, that is equal to up to 5 megapascal. So, these are the three ranges of pressures. So, how much pressure we are applying, depending upon that we will get three types of briquetting process. So, high pressure compaction, this high pressure compaction will not use any binders. If the material having sufficient lignin, so the indigenous binders will be generated and they will bind the particles. Low pressure will obviously require binder, and intermediate pressure process may have binder or may not have binder. Now, we will see different types of machines which are used for the briquetting or for the solidifications of the solids, of the biomass and waste. So, at first we will consider the high pressure case. So, high pressure, normally 4 types of machines are used for the production of briquettes. The first one is piston press, second is screw, and third one is roller press, and fourth one is pellet machine. So, these 4 types of machines are used for the production of briquettes, but these two are having low capacity and these are having very large capacity. So, in developing countries where the applications of densified materials is not very high, in that case piston press and screw press are widely used. Like in our country, the briquettes are normally used in domestic sectors and some very less in industrial sectors. So, these piston press and screw press are mostly used, but roller press and pellet machines, those can be used for large capacity. Now, we will see how the piston press works. Now, see in this slide we are seeing here one piston press. So, material feed is put here, the feed is put here, it passes through the necks and comes in this position, and this is the piston. This piston have forward and backward movement, that is by mechanically by a reciprocating ram powered by a massive flywheel or by a hydraulic drive piston. So, this piston gives some backward and forward movements of the particles or the solids which is coming from the top, and then it is pressed. There is some die. So, this die is present here. So, high pressure is generated due to pistons, and this pistons generates the highest density briquettes. So, this piston press produces very high density briquettes, very high density briquettes. Now, let us see, but one disadvantage is that this method cannot be used for a continuous productions, means only when it will your reciprocating movement will create the briquettes, not continuously. Now, we are coming to screw press or screw extruders. We see here one diagram schematics of the screw extruder. So, feed materials enters into the screw. So, the screw has some shaft which is rotating, this is the shaft, it will rotate, and due to the rotation the material enters into the screw, will get some velocity and it will move forward, it will move in forward direction. See, if it is our screw, see if it is our screw shaft. So, the material is coming here. So, this is some movement. So, this will come and we will be having here some die. So, we are having some die. So, when the material is moving in the forward directions, the pressure is generated. So, there is some pressure gradient. See, P1, here is P2, here is P3. So, P1 is less than P2, is less than P3. So, high pressure is generated here and the die is there. So, from the outside of this we will get the briquette, we will get the briquette. So, here we get 3 zones. The first is your feeding zone here, then this is your transport zone, this is your feeding zone, and this is your compaction zone, or we can so this is the mechanism of the production of the briquettes through the screw press. Now, how the performance of this screw process, screw press is dependent, how this performance can be influenced. So, the performance depends upon flow ability and cohesion of the feed materials. The feed materials which is used here, what is the flow ability and what is the cohesion properties, particle size and distributions. What is the particle size and distribution of the materials, surface forces and adhesiveness of the materials. So, these are the properties which will influence the performance of the screw conveyor, I mean the screw press. The advantage of the screw press is that it produces high quality briquettes, but disadvantage is that that the wear of the screw leads to elevated spare parts. So, cost of the spare part is high. So, this is the drawback, but it requires little maintenance. So, this is all about your high pressure processes or different machines used for high pressure briquette formations. But if we think about the low pressure briquette formation, then these machines will not be used. Low pressure machines. So, as you have discussed that for this case we need to add binders, and the binders may be of organic or may be of inorganic in nature. Organic binders like bitumen, coal tar, molasses, resins and starch etc., and inorganic binders like cement, lime, clay and sulphite liquor. So, any one of these binders can be used, or the mixture of the binders can be used with the biomass and waste, and it can be put inside the machines. So, we will get the briquettes, but in this case the main difference between the high pressure and low pressure processes is that in this case during compaction process the briquettes are brought into shape without giving them substantial strength. So, first step we bring the materials in shape, and second step we give some curing time. curing time, and it gives us green briquettes. It gives us green briquettes. So, what do you mean by curing time? Curing time means we are giving some drying time, it is drying or some chemical reactions. Or burning. So, these things are done. Now, we will see the comparison of different densification processes. So, here screw process, piston press, roller press and pellet mill. So, these 4 types of mills have been compared, although these 2 are used for low scale productions and these 2 are for higher scale productions. We see here the throughput for screw press is 0.5 ton per hour and this is equal to 2.5 ton per hour for piston press, whereas roller press is 5 to 10 and for pellet it is 5. It is very clear from this table that the operating conditions like optimum moisture content are different for different machines, particle size is different for different machines, wear of contact parts is also different, the screw is having the highest wear of contact parts as we have just discussed. Output from the machine in except piston press for all other cases we will get continuously, and specific energy requirement, that is very important factor. The specific energy requirement we see it is very high for screw press and the very low in case of pellet mill. So, bigger the capacity we are having the lower specific energy consumptions, but the limitation is that where we will be using the briquettes. If everything is in a systematic way, we have good demand of the briquettes, we can go for this pellet machines where the energy requirement will be less, otherwise we may opt for these 2. So, our main objective of this densification process is to increase the density of the material. So, we compare the unit density, we get here maximum density in case of piston press, that is 2.5 gram per centimeter cube, that is your 2500 kg per meter cube. But in case of screw press it is 1.0 to 1.4 gram per cc, that is equal to 1000 to 1400 kg per meter cube. But in other cases we see in case of roller press it is less and in case of pellet mill it is also less. So, these 2 gives us higher quality, and bulk density in case of screw press it is 0.5 to 0.6 gram per cc, whereas piston press is 0.1 or less than this. This is very important factor or information. Due to the piston press it gives maximum pressure and so highest density material is used, that is why your bulk density is decreased, and maintenance is also different for all types of mills, and combustion performance of the briquettes is also different. We get very good combustions for the screw press and for the pellet mills, and for these 2 piston press and roller press the performance is moderate. Now, we have got the briquettes, then what we will do with it? That will be used in either combustion or gasification or some other applications. So, when it will be used for further applications, in case of combustion it will give more smokes, just we have discussed, and this the heating values can be improved further. So, the briquettes if we use as such it will be having some disadvantages, those are reduced ignition and burning properties, low heat value and not stable under wet conditions. The briquettes cannot be stored under moist condition for a longer time, that is the disadvantage. So, these major disadvantages of the briquettes can be removed by its carbonization. As you have seen in pyrolysis module that carbonization improves the carbon content in the material and it gives also higher heating value and it removes the volatiles. So, carbonization of the briquettes will also help us to make it more carbonaceous and to reduce its volume, and the volatiles which will be produced for the productions of carbonized briquettes, that can be used for the heating required for the carbonization process. Partially, actually it is heated at 600 degree centigrade. When it is heated at 600 degree centigrade, so partial pyrolysis takes place. So, the vapors come out. So, these volatiles contain some combustible gases like CH4, acid, formic acid, organic acids, etc., or it may contain CO2, it may CO, etc. So, different gases it may contain. H2O may also be available with these things, with the gases. So, these volatiles, this can be used for heating purpose for the production of the carbonized briquettes. So, the carbonization, when and how we will do, this is a big question. We have biomass and waste, intermediate product is briquettes, and then we are getting carbonized briquettes. So, one option, biomass and waste, we can make briquette, then carbonization, carbonized briquette. Carbonized briquettes. Or biomass and waste, you do here carbonization, then carbonized biomass or char. So, this char we can make briquetting, so briquettes. So, now these briquettes can be produced from directly from char or char plus biomass also. So, we have some flexibility, any one options we may adopt. Now, I will show you some example how the property changes due to the carbonization. So, with reference to pine needle and pine needle char and pine needle briquettes. So, we see here we are able to achieve intermediate properties in the briquettes. So, some pine needle as shown here, some pine needle and pine needle char we can add in certain ratio and make briquettes, so that we can get intermediate properties. So, this is the technique through which we can monitor the properties of the briquettes by monitoring the compositions of these two for the productions of the briquette. So, you see here the carbon content in pine needle is 15.83%, pine needle char is 69.15, and for pine needle briquette it is 52.85. For other cases this is applicable, like for mean moisture content, ash content and volatile matter content. So, up to this we have seen that different types of briquettes, the fundamentals of briquetting and the carbonizations and briquetting of the biomass and waste, and when which can be done and how the properties can be monitored. So, up to this in this module, and the second part of this module we will discuss on the rest of the contents. Thank you very much.